Question number 13. 50 centimeter cube of 1 molar HCl. Volume of HCl is given, that is 50 centimeter cube. Molarity of HCl, that is 1 molar, is mixed with 50 centimeter cube of 1 molar NaOH. Volume of NaOH, that is 50 centimeter cube, and molarity of NaOH is also 1 molar as HCl. In a glass calorimeter, that the temperature of the resultant mixture increases from 21 degrees Celsius to 27 degrees Celsius. So 27 degrees Celsius is basically T2 to 27.5 degree Celsius is basically T2 minus initial temperature is 21.0 degrees Celsius. So by this we can calculate the change, which will be equals to 6.5 degree Celsius. Assume that calorimeter losses of heat are negligible. Calculate the enthalpy change of enthalpy per mole. Enthalpy change for per mole, we have to calculate. The density of solution to be considered is, the density of solution is 1 gram per centimeter cube. As we know, in a solution we get water, density is equals to 1 gram per centimeter cube. We have to calculate the enthalpy change per mole. The reaction is neutralization reaction. And the calorimeter is glass calorimeter. So how we can calculate the heat from a glass calorimeter? As we know, the formula is Q is equals to M multiply with the specific heat multiply with the change in temperature. This is the formula. We have no idea about the mass, so first we have to calculate the mass. Mass of solution can be calculated as density, as we know, is equals to mass per volume. Density is given, that is 1 gram per centimeter cube, and volume is 50 centimeter cube of NaOH and 50 centimeter cube of HCl. So the total is 100. So mass over volume, that is 100. We have to calculate this. So this value is in a division. On the other side of the equation, it will be in a multiplication. So 1 multiplied with the 100, it will be equals to mass. So mass will be 100 gram. Put this value in this equation. What is the specific heat? Specific heat is basically 4.18 because water will form in a solution. So Q is equals to M multiplied by S multiplied by delta T. Mass is 100 grams multiplied by specific heat of a neutralization reaction, and we know that water will form 4.18 joule per gram per Kelvin multiplied by change in temperature, that is 6.5. If you remember, we have calculated the change in temperature here, and that is 6.5 degree Celsius. So multiply all these value, it will be equals to 2717 joules. Change it into a kilogram, it will be equals to 2.717 kilojoules. Place the minus of sign because the reaction is exothermic. As we know, neutralization reaction is exothermic. This value is not for 1 mole. This value is basically for, let's see, there are how many moles? Volume of HCl, as we know, is 50 centimeter cube. If we divide this 50 with 1000, it will convert into decimeter cube. 50 divided by 1000, it will be equals to decimeter cube. The answer is 0.05 decimeter cube. Molarity of HCl. Molarity of HCl is 1 mole per dm cube. So by these two values we can calculate the number of moles. As we know, molarity is equals to moles per volume in dm cube. So we have to calculate this moles. Volume is in a division. On the other side of equation, it will be in a multiplication. So molarity multiplied by volume will be equals to moles. Molarity is 1 mole per dm cube. Volume is 0.05 decimeter cube. So moles will be equals to 0.05. Same for NaOH. Volume of NaOH is 0.05 decimeter cube, because this is also 50 centimeter cube. You have to divide that 50 centimeter cube with the 1000. It will be 0.05 decimeter cube. Molarity of NaOH is 1 molar, 1 mole per dm cube. So in the same way, you can calculate the number of moles of NaOH. So there are same number of moles of NaOH and HCl. So the Q, the value of Q, the value of heat that is evolved during the neutralization reaction is for 0.05 mole of each HCl and NaOH. So you have to write here 0.05 moles of each HCl plus NaOH gives you the heat. NaOH gives the heat that is minus 2.717 kilojoules. If there are 1 moles of HCl and NaOH, then it will be equals to 2.717 divided by 0.05, because this value will be multiplied with the 1 and divided with this term. So no need to write 1. So it will be equals to minus 54 kilojoules per mole. This is the answer. This is the enthalpy change for 1 mole. Next, question number 14. In question number 14, hydrazine is a rocket fuel. It burns in the presence of oxygen. Will give you N2 plus 2 moles of water in the form of gas. This is also in the form of gas. Oxygen is in the form of gas and hydrazine is liquid. 1 gram of this 1 gram of hydrazine, 1 gram of hydrazine is burned in a bomb calorimeter. As increase of temperature, there is a temperature increase, that is basically the delta T. 3.51 degree Celsius. The heat capacity of calorimeter. Heat capacity is also given for calorimeter, that is 5.5 joule per Kelvin gram per joule per Kelvin per gram. Calculate the quantity of heat evolved. We have to calculate the quantity of heat that is evolved. Also calculate the heat of combustion of 1 mole. We have to calculate the heat of combustion for 1 mole, for per mole. So this is a bomb calorimeter, so we can use the formula, that is Q is equals to heat capacity multiplied by change in temperature. Heat capacity for bomb calorimeter in which hydrazine is burned is 5.5 kilojoule per Kelvin per gram. Multiply by change in temperature is 3.51 degrees Celsius. So multiply both these values, you will get the value of Q, that is 19.3 kilojoules per gram. This is for per grams. So this is the value of Q for 1 gram. We have to calculate the change and the enthalpy change, the change in enthalpy during this combustion reaction for per mole, for 1 mole. So how we can calculate this? To calculate this, first we have to know about the number of moles for this aid, that how much number of moles are involved to produce this amount of energy. So grams of hydrazines are given. Molar mass of hydrazine, we have to calculate that. The formula of hydrazine is N2H4. Nitrogen's atomic mass is 14. There are 2 atoms plus 4 atoms of hydrogen. Atomic mass of hydrogen is 1. So 14 2 is 28 plus 4. It will be equals to 32 gram per mole. So the total is 32 gram per mole. Mass is given, that is 1 gram. By mass and the molar mass, we can calculate the number of moles. The formula of moles is mass over molar mass. So mass is 1 gram, molar mass is 32. So the total number of moles are 0.03125 moles. These number of moles are for 1 gram. So 0.03125 moles will release 19.3 kilojoules of heat. If there are 1 mole of hydrazine, then how many amount of heat will release during this combustion reaction or during this burning reaction? That will be equals to 19.3 divided by 0.03125. It will be equals to 617.6 kilojoule per mole. Now this is for per mole and this value is for 0.03125 moles. We have to place the minus sign because this amount of heat will be released during the reaction, during the combustion reaction. Next, problem number 50. Octane is a motor fuel. C3H18 is a formula for octane. This is a motor fuel having a mass that is 1.80 grams. This sample is basically burned in a bomb calorimeter having heat capacity. This sample is placed in a bomb calorimeter, and the bomb calorimeter having a heat capacity means C, that is 11.66 kilojoule per Kelvin. Next, the temperature of the calorimeter increases from 21.36 degrees Celsius to 28.78 degrees Celsius. So change in temperature is 28.78 is T2 minus 21.36. This is a change in temperature. So the value will be, by minusing 21.36 from 28.78, it will be 7.42 degree Celsius. This is a change in temperature. Calculate the heat of combustion. You have to calculate the heat of combustion for 1.8 gram of octane. Also calculate the heat for 1 mole of octane. So you have to calculate the heat for 1.8 grams and also calculate for per mole. Heat for per mole of octane. So the simple formula that you have to use is Q is equals to heat capacity multiplied by change in temperature. Heat capacity is given, that is 11.66 multiplied by change in temperature is 7.42 degree Celsius. So you have to multiply both these values. You will get 86.51 kilojoules. This minus sign is basically for the heat evolved for exothermic reaction. This heat evolved is for 1.8 grams of octane. If you have to calculate for per mole, so how you can calculate? The simple way that we did in the previous numerical. Molar volume, molar mass, not volume, molar mass of octane is, formula of octane is C8H18. So atomic mass of carbon is 12, multiply with the 8 plus atomic mass of hydrogen is 1 and the total number of atoms are 18. 12 8 is 96 plus 18, then the sum will be 114 gram per mole. This is the molar mass of octane. Grams are given in a question, so by mass and the molar mass you can calculate the number of moles. So moles will be equals to mass over molar mass. Mass is mass over molar mass. Mass is 1.8 and the molar mass is 114. So the number of moles are 0.0158 moles. So 86.15 kilojoules of heat is for basically 0.0158 moles of octane. We have to calculate for per mole. So how we can calculate it? We can calculate it as 0.0158 moles of octane gives heat, that is 86.15. If there are 1 moles of octane, then how many amount of heat will be evolved? So 86.51 multiply with the 1 and divide with the 0.0158. No need to write 1 because if you multiply with the 1, it will be the same value. So divide 86.51 with the 0.0158. Answer is 5475.5 0.32 kilojoules per mole. This is for per mole. You have to place minus sign here because this amount of heat will be released. So this is the heat change.